The content is reviewed by an engineer and dedicated team of researchers to ensure factual accuracy. The moment your wheels lock, you lose control. But ABS doesn't wait for you to react. It fights your panic in milliseconds. This is the secret system saving your life without you even knowing. The anti-lock braking system, or ABS, is a vital safety feature standard in modern vehicles. This innovative technology significantly helps drivers maintain steering control and avoid dangerous skidding, particularly in critical emergency situations across various road surfaces like dry pavement or slippery conditions. Without ABS, applying sudden or heavy braking can cause the wheels to lock up completely, resulting in an uncontrolled skid and a total loss of steering capability, putting the vehicle and occupants at great risk. ABS actively prevents this hazardous scenario by ensuring that the wheels continue to rotate just enough, even under intense braking pressure, to preserve traction with the road surface. The system works by automatically modulating the brake pressure to each wheel, typically pulsing up to 20 times per second, which helps maintain the optimal level of traction between tires and road. This rapid pulsing action of the brakes ensures that the driver can still steer the vehicle effectively and make necessary corrections, even in the midst of an intense emergency stop. The core components of an ABS system include precise wheel speed sensors at each wheel, electronic hydraulic valves for pressure control, and a central electronic control unit that processes all the data. These wheel speed sensors continuously monitor the rotational speed of each individual wheel, instantly sending real-time data to the central control unit for analysis. If a wheel speed sensor detects that a particular wheel is decelerating too rapidly and about to lock up, the control unit immediately signals the hydraulic valves to momentarily reduce brake pressure to that specific wheel only. This precise and independent control over each wheel's braking force is exactly what sets ABS apart from conventional braking systems, allowing for tailored responses to different traction conditions. In traditional non-ABS systems, applying excessive brake pressure causes all wheels to potentially lock up and stop rotating entirely, leading to a complete loss of traction and directional control. This wheel lockup results in significantly longer stopping distances and renders the driver unable to steer around obstacles, dramatically increasing the risk of serious accidents. Numerous studies and real-world data consistently demonstrate that vehicles equipped with ABS experience fewer collisions overall, with even greater benefits observed in adverse weather or slippery conditions. However, it's worth noting that ABS may result in slightly increased stopping distances on very loose surfaces, such as gravel roads or deep unpacked snow, where controlled sliding can sometimes aid deceleration. Therefore, drivers should never develop a false sense of security from ABS and must always adjust their driving style to match prevailing road and weather conditions responsibly. Beyond everyday passenger cars, ABS technology has been widely adopted across a broad spectrum of vehicles to substantially boost safety standards in diverse applications. Motorcycles, in particular, benefit greatly from ABS as it prevents front and rear wheel lockup, improving stability and control during sudden stops on twisty or uneven roads. Heavy-duty trucks and large buses depend on advanced ABS systems to effectively manage their massive weight and forward momentum, ensuring controlled and stable braking to protect passengers and cargo alike. Even in aviation, aircraft utilize sophisticated anti-skid systems, which are essentially advanced forms of ABS, to guarantee safe and efficient braking performance during landings on various runway conditions. From routine daily commutes in sedans to demanding industrial operations involving trucks and beyond, ABS remains a foundational element in modern vehicle safety engineering worldwide. Its proven ability to prevent skidding, preserve steering control, and shorten stopping distances has undoubtedly saved countless lives and averted numerous potential accidents across the globe. Gaining a deeper understanding and appreciation for this crucial technology underscores the ongoing innovations and relentless progress in automotive safety features today. If you found this detailed explanation of ABS helpful and informative, please give this video a thumbs up. Subscribe to our channel for more in-depth insights into cutting-edge vehicle technologies and safety systems.